I'm Mike Elliott. I'm responsible for developer relations at that. Today, I want to talk about how we detect stolen credential use using our streaming Graph+AI technique, novelty detector. We all know that alert fatigue is a real thing. Our SOC and NOC teams spend much of their time deciding which alerts they should act on and why. Many of the alerts that they receive are interesting, but not really an issue. We need to help these teams reduce the alert noise that they are receiving by creating higher quality insights from all of our data. In our experience, we found that traditional anomaly detection techniques are a poor tool for finding high quality insights in security data. They rely heavily on numeric data. They don't do a good job of representing the user and system behavior, and they don't preserve the context that would allow an analyst to spot the differences between new or unique events or an event that is truly novel. Our approach is different. Let me show you how. The that.novelty detector shifts from numerical analysis to categorical analysis in order to identify high quality or novel events from streams of data. Categorical data is proving to be the elusive key to improving anomaly detection in challenging domains like security. We developed a streaming novelty detector for categorical data that is able to produce real-time insights based on behavioral fingerprinting. This AI technique accurately scores the novelty of categorical data in a stream and reduces false positives. So what is behavioral fingerprinting? Behavioral fingerprinting allows you to pick the attributes of your data that you want to score. Novelty detector reads directly from a streaming log, or it can process stored log files in batches to build a probability graph in Quine. No training or labeling is required. This technique accommodates new types of values, large cardinality, and variable length observations. The model adapts as more observations enter the system. This allows novelty detector to turn high volume, low value data into streams of low volume, high confidence events. Let's run novelty detector through a scenario. In our scenario, we'll detect the use of a stolen AWS credential in a Cloudtrail log file. The log file has over 3.7 million lines. That's a pretty big haystack to look for our needle in. Novelty detector transforms all of the log lines and builds a probability graph. Using the unified kill chain framework, we will identify each phase of the attack. The initial foothold stage, where the attacker is testing the credentials that they have, the network propagation phase, where the attacker probes the permissions the credential has, and the action on objective phase, where in our case, the attacker copies out data that they should not have access to. Our goal is to detect the threat during the initial foothold phase. The latest cost of a data breach report from IBM tells us that in organizations with no security AI or automation deployed, it takes an average of 239 days to identify the breach and 85 days to contain that breach, for a total life cycle of 324 days. That's nearly a year after a security incident. Our goal as security practitioners is to resolve issues before damage is done to the business or prevent security issues altogether. So we really don't want to detect threats in the action on objectives phase. Okay, let's start by taking a look at a sample record from our Cloudtrail logs. The key things that we want to take from this log are the source user, the event source, categorical event time, and the event name. Novelty detector uses a transformation to shape the data into a probability graph. The transformation is expressed as a snippet of code, either in Cypher or JavaScript. That transformation is then applied to each line in the log file as it streams in. Here's what our transformation looks like in novelty detector. The first part breaks apart the log line and creates an observation. The second part finds and captures errors that appear in the log. Errors aren't always interesting, but they help to isolate novel activities. The final part of our transformation stores the event ID and timestamp for use by an analyst when looking for nodes in the graph. Novelty Detector scores every observation that it ingests. The scoring updates over time as more nodes enter the graph. Each observation has a novelty score determined by the most novel component in the observation. The score is always being updated based on what Novelty Detector knows about all the nodes in the graph. Using the API, you can integrate these observations into a real-time analytics application or dashboard. I've already run the data in Novelty Detector. Let's take a look at an observation of typical behavior and how it is scored. Here's an observation from Raul with a novelty score of 0.11. The higher the score, the more interesting the observation is. In this case, Raul called the get object operation from Amazon S3 in the evening, just like he's done more than 46,000 times before in our log file. Next, let's take a look at an observation that is unique but not novel. The observation has a higher uniqueness score of 0.56, but a novelty score of 0.28. That is because categorically, the described subnets operations performed a lot by an Amazon service in the log file. This observation is just the beginning of a new pattern. Here's a suspicious event. Novelty Detector scored an observation at 0.88, indicating that the action is out of the ordinary, but may not be novel. Raul does not typically call the assume role operation in the evening. In 191,000 observations, he only did this twice. Now here's something, a truly novel observation. Novelty Detector gave this observation a score of 0.91, indicating that this is a very interesting observation in the log file. The closer to 1 the novelty score is, the more interesting the observation is to us. In this event, the more interesting component in the observation was that Raul called the list instances operation in the evening. This is very unique in the sample set of over 900,000 list instances observations. This leads me to believe that there may be something up with Raul's count. Let's zoom out from the individual observations and take a look at a group of observations from the log file. As we suspected, Novelty Detector identified evidence of an issue with Raul's account. It may be credential theft or it may be misuse, but we now know that we need to launch an investigation to find out. Let's jump over to Novelty Detector and take a look at some of the observations. As you can see in the beginning of the graph, Raul's credentials are used to do a simple operation like describe target health or assume a role. This observation has a novelty score of 92 and is very out of the ordinary. In the middle of the graph, we see a cluster of observations where Raul's credentials were used to probe the file system and test where the credentials have access to. This observation, where Raul's credentials were used to list instances, has a novelty score of 0.98. This high of a novelty score would trigger a network security analyst to take an action in line with the company's security policy. Finally, we see that Raul's credentials were used to create a snapshot, modify an attribute of that snapshot, and then delete the snapshot altogether. Raul's credentials was used to create a snapshot of data to be copied out of the network. And although we were unable to prevent this security breach, the Novelty Detector AI identified it for us. I invite you to try Novelty Detector for yourself. Visit novelty.that.com and request a free trial. Reach out to me via Slack or email if you're interested in a copy of the data that I used in this presentation. If you want to learn about Quine, the streaming graph technology that Novelty Detector is built on, stop by quine.io. Download a pre-built version of Quine or clone the source repo and start developing streaming graph applications yourself. Thank you for going on this journey with me. I'm available in the chat to answer your questions. Thank you.